Hello, and welcome to a little video about the first day of Target 5C. In all of Target 5C, we will be comparing data sets, but in this video in particular, we're going to be talking about standard deviation. Now, will I show you how to do this way faster than how you're going to see it today? Absolutely. But I don't want to just teach you how to press buttons. I would like you to see the process in which, I guess, your calculator would be doing standard deviation, and I guess how we used to do them before calculators. All right, so what is standard deviation at all? So standard deviation is a measure of how spread out the data is from the mean. Here's the formula. Now, it's going to look really weird, but bear with me. I'm going to write down the formula, and then we'll talk about it. All right, so it starts with an S. There's a square root symbol. There's a sum symbol. Then X with an I, X with a little hat, squared, and N minus 1. Now, what does this all mean? And of course, you can pause the video to write this down. S is your standard deviation. Okay. Next, we have the XI symbol. It represents each individual data set value. We also have X with a little hat that represents the mean. And lastly, we have N, which is the number of data points. Now, the little symbol, the E-looking symbol, or the sideways M, however you picture it, that's telling us about a sum. So we're actually going to be both adding and subtracting in this problem. Okay, now let's take this weird formula and put it into practice. Now, the first thing we need that's inside the formula is each individual data value. Perfect, we have that for number 1. Here they are. We need to find the mean because we do know the number of points. There's 4 data values, so we know that. Let's find the mean. In order to find the mean, we are going to add every single number and divide it by the number of numbers. So 4 plus 10 plus 8 is 28, divided by 4 is 7. Now, move that down here. So 7 is our mean. Wonderful. Now we have everything we need to set up this very long problem. Oh, that didn't copy over nicely. Okay. So we're going to start this way. S for standard deviation equals, I'm going to set up a square root. Under the square root, we take our first data point, 6, minus our mean, which is 7. Square it. Then our second data point minus our mean. Then our third data point minus our mean. And our fourth data point, I don't know why I wrote a plus sign. It's definitely minus our mean squared. And this is why we're going to be doing this on our calculator after. All right, so each of these numbers that we're subtracting comes from our mean. And each of these numbers that begins our subtraction problem inside comes from our data points. On the bottom, we have 4 minus 1. Okay. Now I'm going to show you all the work as we simplify this. All right. Now I'm going to follow order of operations, which means parentheses first. 6 minus 7 is negative 1. 4 minus 7 is negative 3. 10 minus 7 is positive 3. 8 minus 7 is positive 1. And on the bottom, 4 minus 1 is 3. All right, let's continue. We're going to actually square everything. 1 squared is 1. Negative 3 squared is 9. Positive 3 squared is 9. 1 squared is 1. All over 3. And then I'm going to add everything on top. So that's 20 over 3. And that goes directly into my calculator. So my standard deviation is a square root of 20 over 3, which is about 2.58. Again, I promise to show you how to do this on our calculators, which will take a lot less time. But for now, I want to show you what your calculator is doing when we press the buttons that take no time at all. All right, let's do one more of these. Okay, Now, we have our data points. Perfect. How many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8. No, 6. I don't know how I counted 8. That's crazy. I counted 2 in my imagination, I guess. Now we need to find our mean. Let's do it. So we're going to add every single number up. So 36 plus 50 plus 60 plus 75 plus 65 plus 80. And I got 366. I divide that by 6, and we get 61. Now we have all of our pieces to do this very long standard deviation problem. All right, standard deviation equals our first data point, 36, minus our mean, 61. Then 50 minus our mean. Then 60 minus our mean. And 75 minus our mean. And 65 minus our mean. This is why we don't do this by hand anymore. This is awful. And of course 80 minus our mean. Oof. And on the bottom, 6 minus 1. Oh dear. And of course I must color code. There's our means. And then each of these came from our data points, and the 6 came from the amount of numbers we have. All right, let's continue simplifying. Okay, 36 minus 61 is negative 25 squared. 50 minus 61, negative 11 squared. 60 minus 61 is negative 1. 75 minus 61 is 14. 65 minus 61 is 4. And finally, 80 minus 61 is 19. On the bottom, 6 minus 1 is 5. Holy cannoli. We're almost there, friends. We're almost there. All right. Now, following the order of operations, I'm going to square every single number. Negative 25 squared is 625. 11 squared is, or negative 11 squared is 121. Negative 1 squared is 1. 14 squared is 196. 4 squared is 16. And 19 squared is 361. Still all over 5. I'm going to add up every single number on top. I got 1,320. And that goes into your calculator. I got about 16.248, which I rounded to 16.25. That's a pretty large standard deviation. This means our data is pretty spread out from the mean. If the mean is 61, look at that. We got a 36 and an 80. That makes sense. It's far from it. Those numbers are far away. Also, if you take a look at this problem, our mean was 7. Our standard deviation was 2.58. So if you take a look at the numbers on our list, the smallest is 4, the largest is 10, and that's not that far away from 7. Okay. So again, tomorrow I'll show you the faster way of doing this, so I don't torture you as much. And that's it for today. If you have any questions, please make sure to ask me or your teachers. Have a good rest of whatever day it is for you. Bye.